We did something like this at the beginning of the year last year, right? Fire engine and the helicopter.
It was an ambulance.
Or ambulance, yeah. Ambulance and a helicopter. First week of school. And what we said was something to the nature of the helicopter flies really fast and the ambulance travels slowly. Something like that. And this was time. And this was distance. And later in time, the helicopter took off. The ambulance started out at the beginning of time, travels for a while. And eventually, that helicopter, even though it took off later, there was a time when they were at the same distance. That was when the helicopter flies over the ambulance, and it's something like that. We did that in the first week of school. There's two things happening here. You got the helicopter, you have the ambulance. They each had their own equation. We came up with those equations. I can't remember what they were exactly. But we came up with an equation for each of them, and then we put it onto a graph. So this is a person walking. What is this? I can't remember who was who, but one person and another person. And what happens here is that they both start walking at the same time, but one of them is 100 feet ahead. And the person that's 100 feet out ahead of you is walking more slowly, so the slope of the line's not as steep. You're walking more quickly, the slope of the line is steeper. And then out here, the two lines cross one another. So that means at this time, this distance is the same for each of these. What is the time? Look on your graph. What do you have? How many seconds per? Yeah.
10
seconds.
Is it at 10?
Yeah.
Why is mine off so much?
9. 1, 2, 3, 4.
Oh, I have a wreck, don't I? This should be 9. So I have lots of mistakes, don't I? This is 9. This is 10. So we go up. They should cross right there. And how far?
200.
At 200 feet. 200 feet, they're walking to the same place. Good. So that's when this value here is equal to that one. When they're equal to each other, Aiden, are you here? Good. When they're equal to each other, you get the same value for y. Let me show you something. So if you ask a question, when is this 20 times x equal to 100 plus 10x? We're asking, when is this line, the equation of this line, equal to this? It's where they intersect. So take a look at that. What is the x value that works in this? Is it 10?
Yeah, it was 10 seconds, right?
How do you get all of the x's on the same side of the equal sign?
Divide by
Here they're being added, so if I just subtract 10 x's, then there will be no x's on that side of the equal sign. If I go here and do exactly the same thing, then I keep both sides equal. So what is 20x subtract 10 x's? 10x. And then there's just 100 over here. Now, divide by 10, divide by 10. And x is equal to 10. So when is this equal to this? When x equals 10. Check. 20 multiplied by 10, put x as 10. 10 times 10. So what's 20 times 10? 200. What's 10 times 10? 100 is 200, so it works. It's the only place it works, just one place. So, did any of you carry this out yesterday? Your table, did you carry it down to 10?
Yeah.
Okay, so here is a table giving you the answer. There's a graph giving you the answer. And here's an equation giving you the answer. So there's 3 ways to look at it. So here's another set of equations. So they have this one that starts on the bottom and goes up. Distance is equal to 4 multiplied by time. Time is seconds. This line over here is 100 plus 3.5 times the time. So it starts at 100 and it goes up, but it's not as steep because this is only 3.5 times t, but that's 4 times t. So what's the intersection? 200, 800. That's the ordered pair. So at this point right here, you could put a 200 in for t, and the answer would equal 800. You could put a 200 in for t to this equation, and the answer will be 800. So what we call this a system of equations. And right now, what we're really going to do is we're just going to look at graphs with this. We're not going to get into a whole lot of detail with them. We're just going to look at the basic idea of 2 different situations, 2 different scenarios, and when do both of them happen at the same time. So take a look at this one here. So this is money. So the scenario which is given with this one is that the blue line is Sabina, and Sabina has $50 and she is saving $3 every week. I think that's what it is. I think it's 3. So she's getting more and more money in her account, or wherever she's saving her money. Maybe she's digging a hole in the backyard and putting it in there. But Spencer, on the other hand, is spending money. Spencer's starting with $100, but spending 2 every single week, or at least spending 2 more than what he's earning every single week. So Sabina, because it's a positive 3, it's an increasing amount of money, and Spencer's is decreasing, but when do they have the same amount of money? Yeah, it's at 10 weeks. And how much do they have? They both have $80 over here. So that ends up being the intersection between the 2. So do this. Grab your graphing calculator. Let's take these 2 functions and put them into your graphing calculator. So, any idea where we're going to start? Y equals, yeah, we have 2 equations. So, if you have other equations in your calculator, clear them off. Go into y equals, and let's put Sabina as y sub 1, and let's put Spencer as y sub 2, so at least we're all talking the same language. Is that okay?
Like this, these?
Yeah, y equals. Just upper left-hand corner, where you go. Let us know right away if you're not getting them in there.
This is super important. You'll lose,
Not every day, gosh, no. What, is Sabina y equals 1?
What?
Y sub 1 for Sabina, is that what I said?
Yeah.
You can use it for a lot of different things.
Which one's gonna be y sub 1?
You put in the.
Spencer, okay.
What?
That's your Y.
No, what's the difference? I don't get it.
This is gonna be y sub 1,
But mine didn't work. I was like, yeah, I know.
and this is gonna be y sub 2.
Oh,
And then your X, where that is.
100, and then we don't have w, so we're gonna call it x, right? And then 50 plus. Anybody not able to get them in?
wait, you have to.
Y equals.
But when I press.
Yep, there you go. Yep, and you hit that for x.
It's not weird. It's
Yep.
not strong.
Yep, you're good.
There you go.
Yeah,
Yep. And then go into there. I don't know why that.
No, it doesn't show up, don't worry about it.
It doesn't show.
Yeah, might have errors in there. You gotta set your window properly. Okay, who else is having issues? What's up?
Can you grab it?
Oh, you're trying to graph it right away? I didn't say to graph it yet. Okay, so you're gonna, you're y sub 1, so we're gonna just put 100 minus 2 double.
We just leave it at this.
2 and then double.
Stay in your Y equals, cause you probably go through your table and your windows together to make sure that you guys have
And then
the,
it's gonna be 50 plus 3.
understand how to put in
There you go, okay.
your
You guys
values.
You okay? Oh,
There you go, you got
I
it.
know you do, but still, we don't wanna lose you. Anybody else not with these into y sub 1 or y sub 2? Okay, now, some of you started trying to graph it and you said, oh, there's an error and things like that. There's lots of things that cause errors.
Wait, it's supposed to be like this.
Yeah, I think so. I have 100 minus 2x and y sub 1. Is that what you have?
Yes.
Okay, and then I have 50 plus 3x down in y sub 2.
Wait, it's supposed to be W, but.
Yeah, but we don't have a W on a graphing calculator, so we have to in our head say, oh, that's the x value. Because this equation is written in this form. That's written as y equals. You see, this is our y-axis normally, right? But we're doing dollars. So in this case, our A is the same as the W, or is the same as the Y. And this is normally our x-axis, but we're using W. Just to change the variables up, otherwise life is just x's and y's, and that's kind of boring. We don't want math to be boring. Math is not boring. All right, so if we look at this here, we think about it, time is going to start at 0 and go forward. We usually don't talk about negative time. So when you set your window, you're going to have to set your x values from 0 out to maybe 20. Certainly 16. If you want, we could just change it to 16. So you've got to go to window. And your x min has got to be 0. So window's in the top row.
The X min is the X line, the minimum
So
number.
And you hit window. And the x minimum is going to be your left value for x. It's going to be 0. You just type in a 0, you just type right over it. And then you're going to go down. And
Well, what's the
next
x
one,
scale?
is going to be 16.
Well, what do you think it should be? If you're going up by twos,
And then that
then
makes,
that's
that's,
fine.
no, that's a scale. So if you leave it at 1, you want to tick
Two,
mark
or
it.
just leave it at one?
Now your y is going to be your vertical. So where do you want your vertical to go from? Sure, up to, sure, 140 or 120, either one is fine. We'll get it on there.
Scale?
How do we do with the windows?
What should the x scale be?
Well, what would make sense to make your x scale? Every 1 or every 2?
For two, it goes up by two, so your scale for X.
So y minimum is the vertical. That's going to be your dollars.
So what's the lowest number on Y? Yeah.
You guys okay over here? Over? Yep, yep. How about you guys? You okay?
Do you know how to do it though?
Okay, so once you have your windows set, if you hit graph, it should show up.
Yeah, but you're gonna have to let her do it on her own so she can learn. That's the thing. So go back.
Yep. Okay, so sometimes you'll get an error message that will say something about the window range. And oftentimes what that comes from is because you have numbers in your lists, like L1 and L2. And you have that scatter plot turned on, and you need to turn that off. So if you come up with an error message, the first thing to do is to go to second y equals, and make sure you have all of those plots turned off. So if you get an error message on your calculator, go to second, and then the y equals, and turn all of the plots off. And then hit graph. You're still have an error?
How do I get out? What's your maximum?
Second, good. Second, right
What's
next
your
to it.
maximum for the Y?
Okay, so we're still not there?
It should be like 140.
You should do it this way, Kirsten. You should do it carefully.
Sorry, I'm just gonna mess with
Put all the all. Are you gonna have your sister do it?
0 to 16, 0 to 16.
Or my mom? 100.
0 to 140.
Or your mom?
The Y's gonna be 140.
You should really do it like right here. I think it would.
No, graph it.
Cause all this part right here is all this.
The Y's won't turn off.
They're all bad.
So go over, highlight the equal sign. Make it
Yeah,
top.
like right there. Put it right there.
I'll go down. Make it
No!
top. Side graph.
Hey! You're all
You don't have to do that now. And then the scale make it 20. Yes.
I didn't fail. I failed a little bit, but not the
Okay. Do we all have two lines now on our graph?
You're not unhated. Oh, so your minimum's at -10, your scale's off.
Okay, so now what I want you to do is I want you to take a look at the intersection. You can probably just look at it and say, oh, I see about where it is, right?
Yeah.
But there's a way to calculate it. So what I would like you to do is, you see the very top row where trace is?
Yes.
And then you see above that says calc?
Yes.
So you do second and the trace key. And what will pop up, second trace key, what will pop up are the words value, 0, minimum, maximum, and intersect. So you go and you hit number 5, and you go to the intersection, and it will say on the bottom, first curve with a question mark. And your cursor will be blinking on one of the lines. So you hit enter. And then the cursor is going to move over to the other line and be blinking, and it's going to say second curve, and you hit enter. And when it says guess, you hit enter. And on the very bottom of your screen, it should give you the intersection.
X and Y 80.
1080. 1080, right? Anybody not able to make it happen? Yeah, I'll walk through it again. So you do the second calc, which is the same as trace key. And then number 5 is intersect. You just hit the key number 5. And then it will say first curve, and it will be blinking, your cursor will be blinking on one of the lines, and you just hit enter once. And then it will say second curve on the bottom. You hit enter again, and then it will say guess, and you hit enter, and it will list what the intersection is at the bottom of your screen. Yes?
I can't get Hayden's to do the 2 lines and only one.
You crazy puppy. I'm so
Yeah, everything's in there correctly, and I turned the stat clock off.
And I agree over 2 years.
What? Stop! No, it's only one line.
I think you guys
It's like I turned them all off and then I turned them on again and turned them off.
Okay.
2 plus 3, okay, so they're equal
Where would I-
black on the first one, but not on the
You
second.
put it on the
So
dang
that's
floor.
gonna get black.
Still only one line.
I'm so confused. Yeah.
Oh, so that one turned off.
The bullet. No.
Yeah.
I feel like there's a flame.
Yeah.
Did you get the dot where they?
It's only wanting to graph
I
one
feel like I
line.
had a wet, like, right there.
Um,
Let me show you the number.
Oh, there. Did you get the dot? Huh? Where they
I
intersect.
feel like we should do it
Where the
right
F and
here.
Y are at the intersection.
And then you and see how fast it
Yes.
goes.
It would grow.
So we're going with 40.
Not that much.
No.
We are gonna do that.
We're planning to cut my hair.
Are you gonna give it to Locks of Love? You can like give your hair to people to make wigs for
There's
kids.
a glitch. I just reset it. All right. I'm sorry for those of you that had to wait. Next year will be better and better, and it'll be smoother and smoother, and there'll be less waiting time. But thank you for your patience. I appreciate that. So that's how you can do stuff on the graphing calculator. Now, at this stage of where you are at, your work is going to have to be on paper, and you can check with the graphing calculator. We're not just going to be punching everything into the calculators, because then we don't learn it the way we need to learn it. You got to put that away, okay? That's a distraction to me right now, because I want to go back and play with the thing. Look at example 3 with me, please, on the bottom of page 618. Example 3. On the Google Doc, I have the steps here as well for finding an intersection. Okay, so for example 3, they give us a word problem. They say, the Nomad family is moving again. They want to rent a 26-foot truck for a day. Here are 2 plans that existed in 2006. So $50 plus 99 cents a mile to get a moving truck. $80 plus 59 cents a mile for a different truck. So this is a real classic problem. They give you 2 different situations that you can write an algebraic expression for. In other words, you can write the part of the equation that you need to make a graph from. So in each of these cases here, the total cost is going to be that money plus how much money per mile. So each of these have a different starting point. If they move across the street, they don't even travel an entire mile. How much does plan number 1 cost then? $50. How much does plan number 2 cost? 80. But there's a, so plan number 1, if they're just moving in town, is probably a better deal. But if they're moving all the way across the country or all the way up to Alaska from the States, maybe this one's better because the miles are less. They're only 59 cents for each. You start with more money, but you don't build up your cost quite as fast.
What is that page number?
I don't know, it's right here, can't remember the page number. So, if you're gonna graph this one, and you're gonna graph it on paper, these are the steps that you need to take. You write this down, because this is the kind of homework that you guys are gonna be getting. So I'm just gonna do part of it with you. So, step number 1. You need to write 2 equations. That's gonna hold true for all of this kind of work. So if I was gonna do that for plan number 1 and plan number 2, these are usually set up relatively straightforward. They say plus, so we're gonna add. And when we say 99 cents per mile, that means we need to multiply 99 cents times the miles. The only hitch with this one is we've got dollars and cents. So you have to figure out how you're gonna do that. So in this case here, the cost, I'm gonna use that as big C, which is the same as y. Y equals, cost is gonna be equal to, I'm gonna write $50 plus, I'm gonna write 99 cents as dollars. And I would choose the variable m for miles to help keep things straight. I try to pick variables that are simple, that they make sense to us. M is miles, C is cost. So plan 2 then would be the cost is equal to $80 plus 59 multiplied by the number of miles. So there your two equations are. So you get that done. In step number 2, make a table. Goes inside. And make a table with at least 3 ordered pairs. So do it with at least 3 ordered pairs. Four won't hurt. So the way I would lay out a table, if you wish to do 2 separate tables, like here's x and y for one equation, or actually this would be miles and cost, or if you wanted to make a double table, just be real clear which is which. So this would be the cost of plan 1, which could be 50 plus 0.99m. And then we can come over here, and this would be the cost is equal to 80 plus 0.59m. So we want to choose miles that make sense. I tell you, 0 is great, because that arithmetic is straightforward. You told me that this is going to be $50 and this is going to be $80 if they didn't drive anywhere. But don't go and pick 1 and 2 miles, because that's not going to be very good to make a graph with. You might pick like, well, more than 10.
30.
I might do this, I might jump to 100 and see what happens with the numbers. And 100 is easy to multiply. So 50 times 0.99 times 100, this becomes 50 plus 0.99 times 100. 0.99 times 100 is how much? 99. 99 plus 50 is 149. So come over here. 80 plus 0.59 times 100. Picking good input values makes your life a lot easier. 0.59 times 100 is how much?
139. Oh wait, 59.
59. 59 plus 80 is 139. So look at this. It started out more expensive. It's still, nope, it got cheaper, didn't it? This one started less expensive and now it's more expensive.
Wait, but does one have more capacity than the other truck?
No, same truck,
Oh.
2 different companies. So if you look at this, you start thinking about these numbers here. This starts smaller, it ended up bigger. This started bigger, it ended up smaller than that one. So they must cross somewhere. So now what you might do is pick 50. 50 miles. So you have the calculators figured out. 50 plus 0.99 times 50.
99.5.
How much does it come out to?
99.5.
99 and a half. And then this one, Ooh, 80 plus that. How much is that? 109
Yeah,
and 50 cents.
yep.
So about 6.
So somewhere in between the lines cross. You say it's about 60. We need to know exactly where it is. And that's where the tough part with the graph comes in. Because we have to have a graph that's going to show us enough detail. This is not real easy. So we got to use big pieces of graph paper. So graph the two equations. And then you're going to look for the intersection. So that's why I gave you a bunch of graph paper the other day. Make your graphs big to start with, please. It looks like we don't have to go above 100 vertically or horizontally. And we don't have to go above about 150 vertically. So this here is going to be from 0 to 50 and 100. These numbers, you're going to have to go from 0. It looks like if we went to 200, we're certainly going to include everything. Maybe we only need to go to 150. You got to start counting squares and figure things out. So finish that up. See what you can do with it.
Graph paper.
What do you think we're doing?
The one that we did quickly, so if you want to graph this, you need to find it on your graph paper.
Try to make sure that you leave enough room on the edge to label your axes as well.
Okay, you don't have to. Whatever makes you feel comfortable. I just need a magnifying glass. Try to spend your time creating the graph instead of trying to figure out where they're gonna intersect. Cause your calculator will tell you exactly where they intersect. Right now, the point of the lesson is to teach you how to make sure you know how to graph it. Cause you're gonna need to know how to do both for the rest of eternity.
Yeah, there's no shortcuts. I'm not telling you guys to do anything that you don't need to do to be able to progress forward.
And these questions are on your ACT and your SAT and your
A what?
These are cost of 150.
your college, your entries to college exams. These questions will be in your class next year, in Algebra 1. What don't you understand? So it gives you the, so slope-intercept form is basically y equals mx plus b, and it gives you that, and you c equals minus 9x plus 15. So that's the y equals mx plus b. So the y
Next time go bigger. With your scale. Gotta make
Did that
your
just
scale
mess
as
up?
big as you can. Is this one?
Yeah.
You're done? Bingo. You have a good estimate of where they're the same price? So if I was gonna be driving for 75 miles, which one would I wanna use? It's a toss-up, isn't it? Maybe. You don't need a calculator right now. This is all on paper. Yeah, this is all on paper, straight edge. So label your axes. This is horizontal miles. This is vertical cost. So you have to get 100 horizontally. So you gotta look at the number of squares you have and how you can space it out so you can get to 100. So you can count by fives, you can count by tens.
So I'm just gonna put it on the pen. Well,
And then when your points are there, then you connect the lines. Does that make sense? Okay.
Step one, you write two equations, you wrote them, right? Step two, you made a table. I have it up there. Hopefully you have that on paper too. Step three, graph your two equations, and you graph off of those ordered pairs. So you're gonna take 0, 50, 50 and 99.5, 100 and 149. Those are 3 points from that equation.
Makes sense.
For plan one. Where's your table?
No, probably don't, because he tries to mess with you all the
No
time.
shortcuts.
No, he
Got
pretends
it?
to be innocent.
Got the intersection? Sweet.
Do you know where the coordinates are coming from? The X and Y? Yep, exactly.
Hi. How you doing?
Are you warm?
No, connect the points. And in the future, you don't have to label them. Okay, because you have them on the table. So, you're there? You're there? Are you getting there though? You're still moving? Okay.
We're making two different lines.
Yeah, 2 lines. You bet, 2 lines. So this is gonna be one set of points right here. And then this is your second set of points. This will graph plan 1. This set of points will graph plan 2.
So wait, do we want it steeper or?
Spread out on your paper as big as you can go.
Like, no, so when you get to the plan part, you drop it. Do you want it to be a bit steeper or?
The points are gonna dictate how steep it is. How fast they're going up per mile will dictate how steep it is. So this one's gonna be steeper than this one. This will be your steep line, starting lower. That'll be a more shallow line, starting higher.
0, 50, 0, 80, 50.
Not solving other systems, but writing equations that are set equal to one another. Graphing them both, so it's the beginning of it all. Leading place. Hold off on just starting on this because I'm going to tell you what your assignment is. It's not exactly what you're looking at. Okay, I'm getting this one up. They've got two different lines, right? You gotta figure out which points go together. Oh, it should work. Shoot. I give up. I still can't hit it. Good grief. This is bad. Who's got a really good one? Somebody have a really good one? I can't hit the lines for some reason. No, it's not the ruler problem. Can I use your graph? Not the ruler at all, it's me, I can't see. Okay, here we go. Does that work?
Are we supposed to wait until the?
That was pretty decent. So looking at this graph and at your graph, about how many miles is it gonna be the same price? About 75. But it's hard to tell when you have a graph that has such small numbers. So that's where, what I showed you before, where you can set these two equal to each other and solve for m, becomes more valuable. So graphs are really good for estimating. Tables work, but to make a table that had every single mile so we could see exactly when it was, that might be a challenge. But it's not impossible. So, grab your graphing calculator. Put these two into your graphing calculator.
In the graph or just multiply?
Now put them into y equals. So go back to your y equals and clear. We're not even going to graph them this time. Just going to be 50 plus, and m becomes x.
50 plus what?
What are the equations? Yep. But you don't have to graph them. We're going to use a different function on here. What you need? Okay, so once you have it in, you want to hit the second window.
And then this.
And then it's going to say table start. And if you put that at 50, and then there's a triangle TBL, make sure that that's 1. That's the change in your table. And then hit second graph. I didn't say to graph them. Don't graph them. I said like 4 times, don't graph them. You're doing second table set. So start your table at 50 and have it changed by 1. And then do second in the graph key, which is the table function. And now you can look mile by mile at the cost between the two plans. And you can scroll down until they are the same. questions, look, you're way past now, you want these two to be the same, go for 75 miles.
What?
So the n is your x and the y equals, that answer for that question is the y. So what I would suggest is rewriting it as x and y coordinates so that you can see it, because that's a lot of numbers.
So that was a big pile of information.
And the
Okay.
first
So
one,
like for line
which is
one,
50
have the
plus.
x and y.
Yes, Clover.
And then for line two, you have the that you can do them separate. Instead of having like the equation and everything one and seven first for x.
Scroll down. You can start further down. Pretty far down. So the blue one is one off. Walking past you, excuse me. Okay, so I need to clarify what your homework is. First of all, did I give to you yesterday some review problems out of the book?
No.
Okay, good. So then this lab sheet, this 10-1B, fold it, tuck it into your book. Don't lose it, please. Save it for tomorrow in class. So your homework's on page 622. We'll come back to doing more of this type of work that we did in class today. We'll do that tomorrow in class. So page 622, these questions right here, 15 through 18, 20, and 21. Written down, up here. That's all for tomorrow. I'm sorry?